right, good day, everybody. Week 4, Southern New Hampshire Gaming 312. Let's take a look at what the requirements were. All right, we needed to make our widgets, but we needed to incorporate them in C++ instead of just making them in blueprints. So let's take a look here at our UI. We're going to look at the player stats. Okay, so this is our player stats widget that I had to make for our health, hunger, and stamina using C++. So if you look at the graph, there's actually nothing here in the graph. We don't need these. There's actually nothing here in the graph because it's all being run in the C++. I have it set at 0.5. That just lets us know that when we start the game, if it's still at 0.5, then something is not correct. But when we start it, it'll go ahead and pop up correctly. Okay, so let's go ahead and find the interface stats widget. Okay, so what we're doing here is we're setting up our stats widget here, class, progress bar, and text block, and we're just going through setting up our health progress bar and the health text that overlays on top of it for our health, hunger, and stamina, and then the U functions for each of those. The key here is you have to put bind widget as a meta, and if you want to be able to edit in the blueprints, you need to add blueprint read write. And native construct is essentially like a construct for a regular, like an actor class, but in this case it's for the widget classes, so that's a native construct. Come over here. So within our native construct, we go ahead and set up our initial health right off the bat. And what we're doing is we're setting progress to health divided by max health. And then when we update health, we take the differences in the values as long as it's not a null pointer. Okay, we take the F string and we go ahead and put it between two float values that we're using 0 decimal places for the health and max health, divided by a slash in the center there. And then we go ahead and take the health text block and we set the text from that. There we have just some debugging text. Good to always use that kind of stuff if you're not sure what's going on when you're first creating your widgets and stuff. Okay, so here we do it for the hunger, exact same thing, and for stamina, the exact same thing. When you play, if you look in the top left corner, bring this one over here to this screen. Okay, you look top left corner, our widget is updating. I have a border, 3 bars, and then it's updating the text on top. It's not running off tick. It's running on when it is updated. Okay, I believe we link it to our player character. So let's take a quick look at the player character on pulling that because we're also using a decrement value. The health and stuff is actually stored on the player character. There we go, player character.h. So on player character.h, running a delegate. This is if we were going to bind it in blueprints. However, we're not binding it in blueprints. We're binding it here. And we just come down. There we go. So we got our health stats, and then when we do the health update column here, and then we also run a decrement of the stats right here, and then set our health. When it changes, it runs an update. So we'll look in our C++, look at the set health. All right, so it keeps on the decrement. It's setting the health. Move, look, there we go, set health. So what it does is it takes the health, clamps it between the health value change, or takes the value health plus the value, clamps between 0 and whatever the max health value might be, and then go ahead and broadcasts out both of those. And then on the player stats widget, it runs the update health function. And that's all it is. So that's run in pure blueprints. Okay, that was requirement number 1. Requirement number 2 was to build an AI. So when we hit play, I got my AI Jane over here instead of GI Jane. She just say it does a random wander from point to point. I didn't give her any animation blueprints yet, but she'll wander. We have a nav mesh in the area here. If she spots me, she accelerates quickly and keeps updating her position. A little creepy, but that'll work. All right, and to look at that, so we went ahead and blueprints AI. So we got our AI character here. Our event graph. Okay, nothing too crazy here. It's actually controlled with the controller. Okay, close that out, close that out. We'll close character out for now. Okay, so we go ahead and look at the controller when the game. So on target perception updated, we're using sight as the AI perception. So click on AI perception here. We're using sight as our primary, 90 degrees left and right of center. for a radius of 3,000. If the has a tag, so on the player character we have a tag called player, and so if the actor has that tag and successfully sensed, then we go ahead and set up a, if it's false, then we go ahead and set a timer to check again for line of sight. If it's true, then we clear the timer because we have them, and we go ahead and set line of sight true, and we set the player actor as the key name in the blackboard. Okay, so coming in here and looking in our blackboard, we have under the NPC grouping, so you just click here and you can set under input category, you can actually just manually type, and that lets you set up different groups. So under NPC, we have the NPC actor itself and a random patrol location. And then for the player, we have the player object, the player's location, and whether they have line of sight with the player. Okay, looking, continue on here. Oh, let's see. The behavior tree. So the behavior tree, we got a root, come down to a selector node breakdown, and we check, do they have line of sight as a decorator? And then that feeds into the sequence here, whether to execute the sequence or to go to the next one. For here, rotate face the blackboard entry, which in this case it's the player. Behavior task tree, move to player, and then move to. So this basically just gets the location of the player for the behavior task. We can double click on this, and so when this receives an AI execute, cast to the NPC, update the run speed to run as opposed to default float value, and then we go ahead and finish that execution, or if it did not cast, then we go ahead and do a failure. We have walk speed, run speed over here. Okay, so it sets the run speed, and then it moves to where the player's at. Okay, over here, random walk. Okay, find random location. This is the behavior task tree. All right, so we receives the execute. Make a little more space here. All right, so we cast to the NPC. If it's successful, we update the run speed to be the walking speed. Branch, it tries to get actor location and something within patrol radius is a value that we can assign. We have it set to 1,000 right now. Get random with reachable point in radius. This has to use a navigation mesh. If it is true, then we'll set the blackboard value as a vector with a random location, and here I have values set just for testing out, but then we'll go ahead and finish with a positive execute. If it comes out false, we'll not change the value. The player will just stay where they're at. We'll assign the current player's location, or NPC's location, to the random patrol location. We'll just have the NPC stay there. Okay, if the cast fails, it just lets us know and returns a failed execute. Okay, move to. It's just a move to node, and then we'll wait 3 or 4 seconds, and then we'll run it again. If it has the line of, then it'll check again. Does it have line of sight? If no, come back to the right. If yes, then we'll go ahead and run through the line of sight. That's it for the AI player. Pretty simple. All right, some of the other, let's see, number 3, provide clear descriptive inline comments. Okay, so that was in the code. Some of the other things that we've added here. Okay, so we'll go ahead and hit play. We added a fracture system. Hello, or AI Jane. Okay, so we had a fracture system. So when you're looking at your meshes, you can click on them and it'll break them apart. You get 10 resources each time, and it drains the stamina. Okay, berries, we can collect those too. The trees, collect the trees. Okay, come over here, build. So we'll craft. What else might make? Maybe another wall segment and some more roof segments. Okay, hit B to switch over. All right, so add some wall pieces here next to this one that I already have. Okay, add some roof pieces. Maybe add a window piece here, there, and we'll add a floor piece and maybe another roof piece right next to the floor piece. All right, so we got a nice little design right here. Oh, pick that back up. So if you hold right click down, I'm holding right click down on top of that angle roof piece, it actually picks it back up and it adds it back to your inventory here. All right. So we have these placed down. If we exit the game and then we come back in, if we look, it's actually still here. So I actually implemented a save system for the building blocks, and what it does is whatever you put down, it remembers it. And if you pick a block back up, so I'll pick up this roof block here. Sorry, build mode. I right click on the build block. Okay, remove that. Let's exit, start back up, and you'll see that build block has also been removed. All right. In the bottom right corner, working on inventory buttons. So if you have the mouse, you can click on the inventory, crafting, and the building icons instead of having to hit the hotkeys of C and B. All right, to implement that, so basically in the game state, we're storing, we're using a struct. So in our data library, .h, I make a struct where it stores the T subclass of a building, and it also stores the F transform of whatever blocks they are. And then in the game state base class, we build a T array of the building blocks that are already in the game. So then what we do is we come to our game state. We have our event graph. Okay, so we're loading game. So we event begin play, we load. On load, we load from game slot, calling it default. We cast to the BP save. We get the block array. So looking at BP save real quick. Okay, so we have a block array here and save game. So when we save game, it takes in a parameter of a block array, and this is just the struct that we just created, and it go ahead and sets it. And that's it for that. So we get that block array struct. We set our game state block building block array. We loop through it, and we spawn an actor for each instance within the array. For save game, we create a save game object using our blueprint save game that we just looked at. We set our block array based on our game state's building block array, which is also the struct, into the save game struct. And then just for troubleshooting, I loop through, get their display names, and print them out. These three little nodes right here could come out. You just go straight from the set to the save game slot. We save it as default. All right. Looking at the player character. That's the NPC. Player character. All right. So for this one here, okay, so picking up the block. When we pick up the block, we come in here, cast to that building block that we are picking up using the break block, which is the right mouse click in this case, map to the right mouse, get the player controller, find out what's underneath my mouse. We break that hit, so this has to come off the player controller under the cursor. We cast it to the basic building block to find out what it is. We get the basic class, or we cast to the game state so we can get our building block array. Okay, from the building block, we get to class, remove that and the location of that block from the array. So it finds the block type and the transform from the array. And then it returns out and it adds the block back to our inventory by using change item quantity for depending upon the switch on string. I wish I could do a switch on class, but that does not exist. That's something maybe I could write myself, but right now by default there is a switch on string part as the inherent nodes within the engine, inherent functions within the engine itself. All right, let's see. For adding the block, okay, so spawn a real block over a ghost block. So I find the actor location. Okay, I reduce the item quantity, get the game state, cast to the blueprint game state, get our building block array, and what I do is from the block that we just cast, I get the transform and I get the class for that object and add it to the array. So for the game state build struct array, when a block is placed in the world, we go ahead and add it to the array, and when it's picked up, we remove it from the array. And then in the save game, or game state, we then save or load whatever those arrays have. And then there's one last one, so all the way down here at the bottom, okay, event end play, we get the game state, cast game state, and we run save game function over in the save game. And save game goes ahead and sets our block from the game state. So sorry, save game from the game state. So that's this one right here. Pretty simple. So you can drop blocks, pick or place blocks, destroy blocks, and the blocks are stored away within a save game file when you're making them. What else have we done? Also this week we did a modular character system. So looking at different modular character pieces so we can actually swap those out. So let's say I don't like this chest piece and I want another chest piece. I can swap out to like the C model. Now I have sleeves. And they're all based on using the leader node here in the event graph. So on the construction script, we go ahead and we set the leader pose to the root mesh. The root mesh is the head in this case, and then here's the main body pieces, and then we have eye like accessories, head accessories like hair or hats, shoulder add-ons like shoulder pads, and upper add-ons like additional pieces that go on top of the chest armor. All right, force net update, and then we just set the leader pose. So that way everything follows whatever animation blueprint is set up for the root mesh. Everything else will follow that. So on the root mesh, you can see we have the animation blueprint here for the Manny blueprint, and that's under the construction script. Let's see. Yeah, that should be about it. Okay, thank you everybody.